Okay, so we're going to finish up on section 6.3 and 6.4 today, and then tomorrow will be our test on 6.3, 6.4. Remember, progress report's closed tomorrow, so I will be grading this test. It'll be on your progress report, and I'll hopefully get those done sometime tomorrow. All right, so first thing we're going to look at is writing a rule. And we've done writing a rule from a table, right? I give you a table, and you look at the table, and you try to figure out the rule. Well, now we're going to do writing a rule from a picture. Okay, rather than having a table, we're going to look at a picture. So, just to remind me again, what's that formula that we keep using for exponential growth or decay? Yep.
Y equals A times B to the power of X.
Yep, and that's what's going to go in the first blank. In the function, y equals a times b to the power of x. What do you call it when b, this value right here, when that value is bigger than 0, but less than 1, what kind of exponential graph do you have? So that's when the b is bigger than 0, but less than 1. Yeah? That's decay, right? Whenever the b is less than 1, that's exponential decay. So that kind of graph represents exponential decay. And what do you call it when the b value is bigger than 1? Yeah?
Exponential growth.
That's exponential growth. Okay. So that's kind of a review of what exponential growth and decay means. So let's think about exponential decay. As you go to the right, what happens on an exponential decay graph? As you move right, yeah? It curves down. Okay? The graph falls. Okay? I just want you guys to read that. It goes down. Right? So it goes something like that. That's exponential decay. All right, so let's see if we can write a rule for a graph by looking at an exponential growth and decay function. So we're going to look at an actual picture this time. We're not going to look at a table. All right, so here's our first example. So example 1 says, tell whether the graph is growth or decay, and then write a rule for the function. Okay, so you guys you've got that picture on your guided notes. I've also labeled the same 2 coordinates that I've labeled right there. So let's answer the first part of the question. Is that exponential growth, or is that exponential decay? Which one? Yep. Yep, that is exponential growth. Right, so I'm just going to write that off to the side. Okay, so this is exponential growth. And now we have to figure out a formula for that. Okay, we don't have a table this time. So we got to look at that picture and figure out the formula. Here's your formula. If we had a table, how would you figure out the A value? Yeah?
You look where the X value is 0 and you look at the Y column.
Yeah. You'd look where the X value is a 0, and then you'd look for the number that's next to it in the Y column. Well, you can almost use that same idea here. Anybody have a guess what they think that a value is. Yeah?
10.
It's 10. You look for where the x is 0. That's the x value. And then, wherever you see the 0 for x, the number that's with it is the y, and that's the a value. So it's almost the same idea as the table. And we still have to get the b value. So let's write down what we just said, and I'll also write down how you get the b value. Alright, so the first thing you want to do when you're trying to write a formula is they're probably going to ask you if it's growth or decay. So you need to figure that out first. If it curves up to the right, that's growth. If it curves down to the right, that's decay. So you get that by just looking at the picture. So up to the right, growth. Down to the right, decay. Yeah. What was the... Then write the function? We have to still figure that out. We haven't figured out what it is yet. We kind of figured out the a value by looking at the number with 0, just like in a table. But we haven't got the b value yet. So we got to figure that out. Okay, so we got to figure out if it's growth or decay. The next step is to figure out our formula. And the formula has 2 letters in it. It has an a value and a b value. Okay, we need both. Let me just check. I want to make sure these next 2 steps. Okay, that's fine. Okay, so now we're going to write our formula. And remember, this is the pattern you're looking for. Okay, the first number that we're going to figure out is the a. How will you figure out a? Okay, just like I asked somebody if there was a table. You'd look for the number that's a 0, and then you'd take the one that's next to it. Well, we're going to do the same thing. Find the coordinate that has a 0 in it, and take the number that's next to it. That's the a value. So it says, what do you call that number? That number is the y-intercept. Whenever you write 0, something, that number is telling you where it crosses the y-axis. So the a value is the number in the coordinate with the 0. Not the 0, the number with the 0. Yeah. And then this is the part that's a little bit different. We have to solve for b. Now, normally we would be able to just look at a table and see what you multiply by each time. Well, we don't have a table. So what are we going to do? It says use the other coordinate. And the other coordinate is going to have an x and a y in it. And we're going to solve for b in the formula. Let's write down our formula. So what you're going to do at this step is you're going to plug 3 things in, and you're going to try to figure out what b is. You're going to plug in something for x, something for y, and something for a. The x and the y come from the other coordinate. What do I mean by other coordinate? I mean not the one with the 0. So let's go back up and look at our other coordinate. What's the other coordinate there that doesn't have a 0? Yep. 112. And the 1 is a which value? X or Y? Yep. 1 is the X. And then 12 is a Y. That's the X and the Y I need to use. 1 is X. 12 is Y. All right. So we got those two. And it says for A, look at your coordinate. Look at the one that has a 0. And it's the other number. So what's the number that's with the 0? Yep, 10. That's the A value. It's always the number that's with the 0, whether it's in a coordinate or in a table. So A is 10. Now, plug them in. Plug in the X, the Y, and the A, and then solve for B. Okay, so let's see what we have. So 12 equals 10 times B, and then X is on 1. Okay, so PEMDAS, you always simplify your exponent first. What's B to the first power? Yeah, B, and that's always going to happen, because if it wasn't to the first power, it'd be a little bit more complicated. Right? So you're always going to end up with something like that. B to the first power is just B. And how would you get the B by itself and put the 10 on the other side? Yeah? So this is multiplication, so we can't undo multiplication with subtraction.
We have to divide by 10.
Yeah. So we're going to have to divide each side by 10. That's gone. And we get B equals, and let's just type that in the calculator. 12 divided by 10. And that's going to give me 1.2. Okay, so my B value is 1.2. Right, now you've got the two things that you need to write the formula. You have A, and you have B. So now you write your final answer using the A and the B that we just figured out. So B is the only thing that's a little bit more work, because you can't just look at a table. All right, so let's write our final answer to this problem. Using the A and the B value that we just figured out, could somebody tell me what my final answer would look like? Yep.
Y equals 2, y equals 10 times 1.2 to the power.
Perfect. 10 times 1.2 to the power of x. Okay, let me type that in on the calculator and see if it actually looks like that picture. Let's see. All right, so we got y equals 10 times 1.2 raised to the x. Okay, and I'm going to set my screen to look like this. So I'm going to go up to 20 and over. Okay, let's do it like that. So let's go up to 20, and let's go, I think that all looks good. Okay, so that's typing in the formula that we just got. Let's look at it. does that picture look like that one? You think, Sean? Yeah. It looks like it crosses the axis up at 10. That one crosses up at 10, and it's curving up as you go to the 8. So it's perfect. Okay. Any questions on that? All right, so let's try example 2, which is one that I'm going to let you guys try. This is on the back of your guided notes. So you should be able to read the coordinate. I know it's a little small, but the first one is 0, 8 up at the top, and the lower one is 1, 4. So see if you can first identify if it's growth or decay. The directions are on the board. They are on your guided notes. So tell whether the graph is growth or decay, and then write a rule. So really, it's just like the last. All right. So first thing on your notes, it said to tell if the graph is exponential growth or decay. Which one is this? Is this growth or is this decay? Yeah.
Decay.
Yes, it's decay. So this is exponential decay. Now, because it's decay, that tells you what you should be looking for a b value. Anytime it's decay, what do you know about b value? Yeah? It should be less than 1. If you get a b value more than 1, then you did something wrong. All right, so let's write down our formula. Okay, Natalie, what's the formula that we've been using?
Y equals a times b to the power of x.
A times b to the power of x. And one of those letters we can figure out pretty quickly just by looking at the coordinate. It's the same thing we'd kind of do if it was a table. Which letter can we get just by looking at the coordinates? Yeah? A. And which coordinate do you want to look at to figure A out? The one that has the 0 in it. So look at the 0, 8. And what is A looking at the coordinate 0, 8? 8. It's always the number that's with the 0, whether it's in a table or a coordinate. So A is 8. Okay, so we know that. But I need 2 other things to figure out B this time. What are the other 2 letters we need to find B? This is the stuff that's a little different. Yeah? We need an X and a Y. Now, we already used the number from this coordinate. So we don't want to go back to this one. We want to go now to the one that doesn't have a 0. All right, so what's the X value that I'm going to use? Yep, 1. And the Y value? 4. X is 1, Y is 4. Now, what are we going to do with these 3 numbers? We got to do something with them. Yep. Yeah, we're going to put them into this equation. So the Y is going to be a 4. The A is going to be an 8. The B, well, we don't know. That's what we're trying to figure out. And what's the X? Yeah, 1. And when you raise B to the first power, you always get what? Yep. Yeah, you get itself. So that's just 4 equals 8 times B. Now, to get B by itself, we got to get rid of the 8. How do we get rid of the 8? Yep. Divide everything by 8. That's gone. That's gone. And you can leave B as a fraction, but you should reduce it if you can. What is 4/8 reduced to? Yep. 1/2. Okay. So there's B. There's A. Now we can write the final answer the way we normally would. What's my final answer going to look like? Just like we were doing it from a table. We know A and B now. Yep.
Y equals 8 times 1 half the power of x.
Yep. Perfect. Y equals 8 times 1/2 to the power of x. Any question on that one?
And Mr. Hager, you did say that if it's in a decimal form, that's fine too, like 0.5 would be fine.
Yep, 0.5 would be fine. The only thing I wouldn't do is if it was 0.5, I wouldn't do something like this. Just the notation there looks a little confusing to me with a dot there and then another dot for a decimal. I would probably use parentheses. And now to me that looks a lot clearer. So whenever I have decimals, I don't try to use the dot for multiplication next to a decimal because then it looks a little confusing. Okay, so let me put down a formula that we had. This is one that we did, I think, 2 days ago. It was y equals a times 1 plus r to the t. That's the formula we did right before we did the bank interest rate formula. This is for exponential growth. If you change one thing in that formula, it becomes the next formula on your guided notes, which is exponential decay. Does anybody have a guess what the one thing you have to change in this formula is? And it goes from being growth to decay. Change one. Yeah? Yep, if you switch the plus to a minus. Alright, so I just wanted you guys to write this part down. So just like we did with exponential growth, we're going to use almost the same formula for exponential decay. So this is the formula for exponential decay. Just like the formula for growth, except the only difference is the plus becomes a minus. So A is still an initial amount. And remember, initial amount can be lots of different things. Initial amount of people, initial amount of money, initial amount of bacteria. It can be all kinds of things. R is not the growth rate, but it's called the decay rate. And remember that R has to be a decimal. So if they gave you an R of 3%, you got to do 0.03. 15%, 0.15. Right, and T, just going to simplify that, T is just the time period. So it's usually measured in years. That's it. So any question on the formula? Okay, so let's look at example 3 and see if we can figure that out. This should say 3. Okay, so it says, just make sure the numbers match up. The number of acres of pine forests decreased in the western U.S. from 1963 to 2002 by 0.5% every year. Okay, so decreased by 0.5% every year. In 1963, we started out with 41 million acres of forest. They want us to figure out how much forest would be left in 2002. All right. So the first thing you have to figure out when you're doing this, is it a growth problem or a decay problem? Because that's going to control which formula you use. When you read that word problem, there's a key word in there that tells you whether it's growth or decay. Does anybody see the word that tells you that? Yeah? Decreased. Decrease, something's going down. That means decay. So since it's decay, that's the formula you're going to use. Okay, so let's copy that down. A times 1 minus r to the t. Okay, so on the right-hand side, how many letters does that formula have? Just on the right-hand side. Yep. 3. We're going to have to find all of them. They're all given. They're either given or we can figure them out from the problem. What are the 3 letters, E?
They're A, R, T.
A, R, T. Okay, so let's go through what's A. A is some type of amount that you started with. Does anybody see a number in this problem that represents something we're starting with? Yeah.
41 million.
Right, 41 million. That's the number of acres we're starting with in the time frame we're looking at, 1963 to 2002. So 41 million. That's the A value. We can just write it as 41. You don't have to put 0, 0, 0, 0, 0, 0, 0. Just remember that 41 is million, not the number 41. Okay, what about R? What does R stand for? Yeah, that's the decay rate. Okay, you had that right on the other page. R is the decay rate, but it has to be a decimal. Okay, what's the decay rate that they give me in this problem? Before we change it. Yeah?
0.5%.
It's 0.5%. And what do you do with this decimal to turn it in, to get rid of the percent sign? You have to take this decimal and do what with it? Yeah? So if we look back at like this example of, like, if I did 15%, my decimal's right there, and then look where it ended up. So how many does it move? Yeah? 2 to the left. Move your decimal 2 to the left. Well, if I move 1, it's there. If I move 2, I don't even have something here. So what do I need to put right there? Yeah? A 0. So that's 0.005. Okay, and what does T stand for? Yeah, time. And I said that time is usually measured in, yeah, years. So time is the number of years since the start value. Okay. We're not looking at if you plug in 2002 for T, that means you want to know what's going to happen in 2002 years from now. No, we don't want to know what happens 2,000 years from now. We want to know how many years have gone by between 1963 and 2002. So like, if they wanted to know 1964, T would be 1, because 1964 is 1 year away from 1963. How are we going to figure out how many years 2002 is from 1963? Yeah?
You take 2002 and subtract from 1963.
Yeah, take 2002 and subtract 1963, and that tells you that it is 39 years apart. That's the value for T. Any question why we're putting in 39? That's how many years have gone by that they want us to figure out. Yeah.
Sorry, drink water.
Yeah. Okay. Now, let's fill in everything into our formula. Okay, y equals, Maya, what's A?
41.
41. That's a 1. Well, Anaya, what's my R?
0.005.
005. And how many years are going by in this situation? Yep. 39 years are going by. So what would have made this problem a little easier is if they said, we had 41 million acres of forest, find how much forest 39 years from now. Then you wouldn't have had to figure out the 39. But they didn't word it that way. Right, so now we're going to type that in and see what we get. Okay, the way you're going to put that in is exactly the same on this calculator as the ones that you guys borrowed. 41, parenthesis, 1 minus 0.005 raised to the 39. Now, this is decay. So, should the amount of forest be more? Or should the amount of forest be going down? Yeah?
Should be less.
It should be less. Maybe they're cutting down forest to make, roads, or cutting it down to make use for houses and stuff like that. But the amount of forest should be less, and it is. So we'd have about. Now, does this mean that there's only 33.7 acres of forest left? What's that? What is that 33.7? It's not just 33 acres. It's million. Yeah. So we'd have about 33.7 million. What did they measure it in? Was it acres? Yeah, acres. Left. So we started with 41. Now we're down to 33.7. Question on that? Okay, so just a reminder, I will be after school today, but I can only stay after till about 3:15, maybe 3:20, because I have to be somewhere by 4 o'clock. Okay, so the homework is 6364 online, and I think it says part 4. Let me double check.